Okay, everyone. We are on rationals, so we made it to the final section in this prerequisite. So rationals are something that were covered in Algebra 2 for the first time. And those of you that just took Algebra 2 last fall and spring, or last year, I guess, rationals was covered during virtual learning, so I know that this was something that maybe not all of you understood fully. So I'm going to try to go a little bit slower through this section. And if you feel like you're not getting it, make sure you reach out to your teacher, because this is definitely something that will be used in the future in this class. So we want to make sure you have a good understanding, but again, realize that maybe you didn't get a good preview during Algebra 2. So those of you that just finished pre-calculus, you should feel more comfortable with this because you've had a couple years of it. So just know that we're on different levels here. Okay, so again, with our warm-up, you're going to factor these completely. So this is a review from your last section. So pause the video and then factor them. Okay, so I'm going to give you your answer. And so when we check this, we have to check the inside, this 4. So this is negative 8x, and the outsides are going to add or multiply to give me 12x, and those are going to add to give me 4x. So that middle term is correct. So this 3x and x gives me 3x squared, and negative 8 and 4 give me negative 32. And then number 2, we're going to factor by grouping. And so I'm going to get x squared and then x plus 3. And then I'm going to factor out a negative 16 because we want this to match. We'll be left with x plus 3. Now we're going to take out the x plus 3 out of both of these terms. Notice that there's one subtraction sign right here between this is one term and this is one term. So we're taking out the x plus 3 out of both terms, and we're left with x squared minus 16. Now, this is factored because we have 2 binomials and we have multiplication. So that's factored. So like 4 times 3, those are the factors of 12. But this term can be factored further. So notice that this is a difference of squares. So we're going to factor that again, and I'm going to get x plus 4, x minus 4. Okay, so now let's talk about a rational function. So this is what a rational function looks like, and this is just the basic rational function. So when it's got just a number on top over a variable, so this is the graph of 8 over x minus 2. So when we talk about domain, when it's like a quadratic or a polynomial, domain is your x values that you can substitute in, and that means you can substitute any of them in because there's no reason why you can't. When we start getting into division, remember that a number, if you have a number divided by 0, that is undefined. Okay, think of it as no. Okay, if you have 0 divided by a number, that's okay. That's just 0. So remember, we can never divide by 0. So in this graph, notice that it kind of has this jump right here. Remember, this is called an asymptote, and that is actually happening right at, if these are 2, 4, 6, 8, this is happening at 2. Okay, so our domain for this function is everything except for that value, because it's getting closer and closer to that value up here and getting closer and closer to it over here, but it's never hitting that. So if we look at this denominator, x minus 2, we don't want the denominator to be 0. So when I solve this equation, x equals 2 is where my asymptote is. That is the value that is going to be excluded from our domain. So x cannot equal 2. So x minus 2 cannot equal 0. So x cannot equal 2. So if we were writing our domain in interval notation, we would have negative infinity to 2, and we're not including 2, union 2 to positive infinity. And so then this would be our domain. And again, this is not sure why that happened. But this isn't technically, x is an element of that. That's something that we'll talk about more in the future. Okay, so domain are my x values as I move left to right on the graph, and x equals 2 is the only thing I cannot substitute into that equation. Okay, so let's practice. What numbers need to be excluded from the domain of this rational expression? Notice it's an expression because there's no equal sign. Okay, so if I were to graph it, it'd be a function, an equation, something like that, but this is just an expression. So the domain of this function, again, we're looking at just that denominator. So we need that denominator, and that cannot equal 0. Okay, so reach back into your brains from when you learned about quadratics. If we're trying to solve this equation, we have to have a way to figure out what x is. So first thing I'm going to try is factor, and that's what we practiced in our last section. So this is factorable. X plus 6, x minus 3, and then that's not equal to 0. So then we're going to solve that. X plus 6 not equal to 0, and x minus 3 not equal to 0. So x cannot equal negative 6, and x cannot equal 3. So what numbers need to be excluded from the domain of the rational expression? Those are our numbers that are not in the domain. So when we would see a graph of this, you'd have a jump at negative 6 and at 3. Okay, so simplifying a rational expression, when you're doing this, we're going to factor our numerator and our denominator. So like in the last one, we factored the denominator. And then if there's any common factors, we want to divide those out because we're trying to simplify. If we cancel a variable expression, you must write the disclaimer regarding the domain. So you can't just cancel it out. It still cannot, let me show you an example. It cannot be included in the domain because it was in the expression originally. Okay, so let's do an example. So example 2, we're going to simplify this. So first thing we're going to do is factor. So first thing, factor. So on the top, we have x minus 4. That doesn't factor. It's already factored. I'll just put parentheses around it. On the bottom, we're going to factor out our GCF, which is negative 7, and we're left with x minus 4. Notice that we have an x minus 4 on both the top and the bottom. So we can cancel those, and I'm left with just negative 1/7. And here we don't have any x's, so it doesn't really make sense, but our disclaimer is that x cannot equal, we had an x minus 4 in the denominator, so x cannot equal 4 is our disclaimer. So this simplifies down to negative 1/7, but if I were to plug anything into the original equation, I could not plug in 4. Or the original expression, I should say. So this is my answer. And we have to write this disclaimer here, okay, or our restrictions on the domain. Okay, so try this next one. Pause the video. Okay, so we're going to factor. So we have 3 and then x minus 6. And then on the bottom, we're going to factor out a 6x, and then x minus 2 is what's left over. So what happens here is the x's, nothing can cancel from the x's, but we do have this 3 and 6 that we can reduce. So this 3 is going to cancel, and that's going to become a 2 down here. So x minus 6 on top, and then 2x, x minus 2. So our disclaimer here, what x cannot equal, we look at the denominator, and if I were setting that equal to 0, x could not equal 0, and x could not equal 2. So this is my final answer. Okay, example 4. Again, try it on your own. Okay, I'm going to factor the top. Factor the bottom. Notice that nothing cancels. So this is as simplified as it gets. So we don't have to do anything really. I'll leave it in factored form. But then we're going to write what m cannot equal. And so if we look at the denominator, m cannot equal 0 or 4. Okay, example 5. Notice that we have 3 minus x and we have an x minus 3. Those look very similar, but they're not the same. But we can make them a little bit more similar, I guess. We can factor them. So 3 minus x, if I factor out a negative, so 3 minus x, if I take out a negative, oops. If I take out a negative, I'll be left with a negative 3 plus x, which is x minus 3. So back up here, when I write this, I can write it as negative x minus 3 over x minus 3. So they are the same, we just have to take out the negative to factor it first. So they're not the same, but but all we're left with is a negative 1. So this is negative 1, and we have to write our disclaimer. There was an x minus 3 in the denominator, so x cannot equal 3. Okay. 2 more examples. Go ahead and pause it, and then I'm just going to write the answers so these are worked out for you. That factors like that, and then I'm going to take out that negative again. And so then I'll be able to cancel that. So I have an n plus 2 over negative 1. That looks kind of funny. Remember, our negative can go in the bottom or the denominator or the numerator. So I'm going to move it up top. And that's okay. That's a correct answer. Or you could write it as negative n minus 2 if you want to distribute that. And our n cannot equal, if we look at the denominator originally, if that was set equal to 0, x or n could not equal 2. And then our last example over here, we're going to factor the top. So I'm going to factor out an x. And on the bottom, I'm going to factor out an x. And then it looks like we can factor again. So I have x, and then x plus 5, x minus 1, it looks like. And x plus 1, x minus 1. That was a difference of squares. So it looks like we can cancel out here. So we have x's that can cancel and x minus 1s that can cancel. And so I move these down a little bit. we're left with x plus 5 over x plus 1. And then our disclaimer, it can equal 0, -1, or 1. Because it was originally in the denominator. So just a notation clarification, if I'm writing a disclaimer, that's not how I write the domain, okay? A disclaimer we write like n is not equal to 2, but the notation for that's not how I would write the domain. So if I was asked for what is the domain, you would write it like this. It's stating what x can be. A disclaimer is just saying what x cannot equal. So just a kind of nitpicky notation thing there. Okay, so this is the end of part 1 of day 1. So you can continue on to part 2 if you'd like right now, or you could practice some before that.